Alright, section 6.6, similar and congruent triangles. Okay, what is that? Okay, so this one we're going to know the properties of similar triangles and know the properties of congruent triangles. Okay, this is not going to be as in-depth as the 6.1, so don't worry. In similar triangles, the corresponding angles have the same measure. We say that the corresponding angles are congruent. In similar triangles, the lengths of the corresponding angles are proportional. Remember proportional, think back to that. Okay, let's take a look at this. Given two triangles, A, B, C, okay, so here we are, A, B, C, and A, X, Y, with, okay, notice that what they're saying is the angle ABC is the same as angle AXY, and okay, they're both 90 degrees. Okay, notice these are actually the same. Okay, so separate the two triangles mentally. Here's what they would look like, but notice they have exactly the same angles here. Okay, no matter what, this is a right triangle. Okay, this right here is a right triangle. Okay, both of these, all the sides are going to equal up to 180 like they're supposed to. Okay, so that's what they're meaning by this. Okay, so let's kind of take a look here. They can show this here. Notice that the CAB, okay, CAB is the same as YAX, and it kind of just keeps going. Therefore, the corresponding triangles are congruent and the triangles are similar. They have the same angles. Okay, the proportions are going to be the same. Okay, let's kind of continue on and take a look at this. Okay, refer to the triangle on the left here. Notice if AB equals 4 centimeters, okay, AB, BX equals 2 centimeters, BX, and then BC, here we are, okay, what is going to be XY? Well, notice once again, we're dealing with proportions, okay? So if we think about that, let's kind of come over here where they're saying they'll show it to us, okay? Notice what they're saying here is this. Look, we're still dealing with proportions here. Okay, so notice you can come in here and multiply this here and you're going to get the 18. That's what they get here. 4 here, notice what's happening here. Okay, they're cross multiplying and then we're dividing by 4. This literally turns into a proportion problem. That's exactly how these work out perfectly. This one gets a little bit convoluted because of all the letters, but if I got rid of all the units here, you would literally just see, let me pull this up here, you would literally just see a proportion that you would know how to solve. If I showed you, notice they're using here, let's see here, they're using the 2 one here, so we've got this 4 to 6, 3 to XY, okay? Well, notice this just literally just turns into a proportion problem. So, makes it pretty straightforward, makes it pretty simple. So, and the reason they got this 6, notice they have this 4 plus 2 here. So you got this 4 over 6 equals 3. Well, go back to your proportions. And that's technically, not technically, that's exactly what you're seeing right now. So you would have 4x equals 18, divide off the 4. And this is what they're getting right here. It's literally going to be a proportion problem. Okay? Let's do another one here. Okay, a very tall, magnificently decorated tree was on display on an outside patio area at the mall during the month before Christmas. Joanna knew that the height of the nearby lamppost, right here, okay, was 10 feet. At 2 p.m. on Tuesday afternoon, she measured the shadow of the lamppost to be 3.5 feet, okay, long, and the shadow of the tree to be 21 feet long. With her understanding of similar triangles, Joanne was able to calculate the height of the tree. What was the height of the tree? Well, let's come over here. Let's remember here that we have similar triangles. So let's take a look at this. Let me just kind of draw this out a little bit easier to see. So we've got one triangle, a very large one. Okay? And then we've got one triangle that is very, very small. Okay? That's going to be the lamppost one. We know here is 10. Okay? We know here, though, we're going to change this to 3.5. And we know the shadow here is 21. And here, like they're using here, we've got x. Notice this can turn into a proportion very easily. We can have x over 21 is equal to 10 all over 3.5. And knowing what we know about proportions, I can come here and go, well, 3.5x is equal to 210 divide off my 3.5. Okay, and I'm going to do this on the calculator. 210 divided by 3.5. Okay, and I get 60. Okay, so I know the height of the tree is 60. Well, what are we on to? 60 feet. And so that's how we can use our knowledge of congruent angles. Okay, so let's continue on here. Properties: two triangles are congruent if the corresponding angles have the same measure, the lengths of the corresponding sides are equal. Okay, notice side, side, side. If two triangles are such that the lengths of the three sides of one triangle are equal to the lengths of the corresponding sides of the two triangles, then the two triangles are congruent. Notice 15, 15, 10, 10, 12, and 12. Okay, triangles ABC is congruent to triangle DFE. Okay, let's look at some other ones here. Side, angle, side. Okay, notice we got 10, 10, 12, 12. Okay, if two triangles are such that the lengths of two sides of one triangle equal the lengths of the corresponding sides of the other triangle, and the angles included and the angles are the same. Okay, so we notice we got side, side, angle, angle. Okay, or side, angle, side. Sorry. Okay, that also means that they're congruent. Okay, so continuing on here. Okay, angle, side, angle. Okay, notice we've got two angles that are the same and a side. So it goes angle, side, angle, angle, side, angle. Okay, this side can't be over here. Okay, it has to be angle, side, angle. Okay, that's exactly how that would work. So we're doing a quick example here. Let's take a look at this last one here. And notice they're giving an example of one that has a side, angle, side. Well, remember that. Side, angle, side. Well, this side matches that side. This angle matches that angle. This side matches that side. So side, angle, side. Side, angle, side. This is going to be one that's going to be congruent because of that relation of side, angle, side. And so that's how these are going to go. Pretty straightforward, a little bit, I think a little bit more simple than the section 1, but it's to each their own.